Ladies and gentlemen, boys and girls, welcome to another video. Please hit the like button, hit the subscribe button, and hit the notification bell so you will be updated on all my future content. Most importantly, please hit the subscribe button. So this video is going to focus on fraction models, visual representations of fractions, and explaining what a fraction is. So a fraction is really a parts to whole relationship. The denominator, the bottom number in the fraction, that represents the whole or total amount of pieces. The top number in the fraction, the numerator, represents the parts filled or unfilled. So for example, the fraction 1/2 has a total of 2 parts. Two equal parts. And one of those 2 parts are filled. So this is a representation of the fraction 1/2. We have 2 total parts. Half the fraction's filled, half of it's unfilled. So we have 1/2 of the fraction unfilled, 1/2 filled. So 2 total parts, and one of those 2 parts are filled. Now let's say we had the fraction 2/2 or 2/2. This fraction model would represent 2/2. We have 2 total parts, and both parts are filled. And whenever the numerator and the denominator are the same, that equals 1 whole. So 2/2 would be equal to 1 whole. So next we are going to go with thirds. It's the Mr. Camilleri show. It's the Mr. C. It's the Mr. Camilleri show. Shout out to Mr. C. So if I wanted to make a fraction model for 1/3, 1/3 would have 3 total parts. So we have 3 equal parts within 1/3. Now keep in mind, my drawing might not be exactly to scale, but the fractions, they're supposed to be 3 equal parts. Even if one part looks a little bigger than the other, that is not intentional. So 1/3 would have a total of 3 parts total, and one of those 3 parts would be filled. So right here we have our fraction model representing 1/3. Now let's say I wanted to represent 2/3. If I wanted to represent 2 out of 3, we would still have 3 total parts, but 2 out of the 3 would be filled. So this is a fraction model that represents 2/3. We have 3 total parts, 1, 2, 3, and we have 2 of those 3 parts filled up. Now if I wanted to represent 3/3, that would mean that we have 3 total parts, 3 equal parts, and 3 out of those 3 parts are filled. And as I've said before, any fraction where the numerator and the denominator is the same is equal to 1 whole. So 3/3 would also be equal to 1 whole. All right. Now I'm going to do some fraction models representing fourths. Shout out to everybody tuning in. Please hit the like button. It helps the algorithm. So for fourths, we're going to have 4 total parts. 1, 2, 3, 4. Now, if I wanted to make a fraction model that represented 1/4, one of those 4 parts would be filled. So the fraction model representing 1/4 is below. In this fraction model, as you can see, we have 4 total parts, and 1 out of those 4 parts is filled. Now let's see what 2/4 would look like. So if we have 2/4, we still have 4 total parts, but 2 out of those 4 parts would be filled. So this is the fraction model representing 2/4. We have 4 total parts, and 2 out of those 4 parts are filled. And 2/4 is equivalent to 1/2 proportionally. As you can see, this square, unlike the other square, has 4 total parts instead of 2, but as you can see, about half of the square is filled. 2 out of the 4 parts are filled. So the 2/4 is equal in size to 1/2. Now, if I wanted to make a fraction that represented 3/4, the total would stay the same, 4 total parts, but I would need to shade in another one of the parts. Now we have 4 total parts, and 3 out of those 4 parts are filled. So the fraction model representing 3/4 is below. Now, if I were to fill up this whole square, that would be 4/4, and so 4/4, 4 total parts, all 4 parts are filled, and any fraction where the numerator and denominator are the same is equal to 1 whole. So 4/4 would equal 1 whole. All right, next I'm going to do eighths. I'm not going to do examples of all the different fractions within eighths, but I'll do a couple. So again, oh, you tried to donut you tried to donate. Thank you so much. I appreciate that. But nah, I'm not eligible for that yet. In order to donate money, you need to be in the YouTube Partner Program. I'm not in it yet. I have enough subscribers, but I don't have enough watch time yet. I need about 4,000 hours of watch time. I'm only at like 1,800, so I got a ways to go for that, but I appreciate it. All right, so if we're gonna go with eighths, we need 8 total parts. And those parts should be equal. Again, if it doesn't look exactly equal, you know, my drawing's not that precise, but it's supposed to be about equal. I'm gonna try to make it as close to equal as possible. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total parts. Let me even this line out here. Now, if I wanted to make 1/8, I would shade 1 of the 8 parts in. Now, this fraction model would represent 1/8 because we have 1 part that's filled and we have 8 total parts. 1 part's filled, 7 are unfilled, and we have 8 total parts. So this would represent 1/8. Now, if I wanted to do 2/8, it doesn't matter which additional square I shade in. I could shade in this one, or I could shade in the one below, but whichever one I shade in, if 2 out of the 8 parts are shaded in, then that would represent 2/8. So now we have 8 total parts. 2 of those 8 parts are shaded in. This fraction model represents 2/8. Now, if I wanted to make 3/8, I would simply shade in another part. Now we have 8 total parts, and 3 of the 8 parts are shaded. So this is the fraction model that represents 3/8. I'll do 2 more examples for eighths, and then I'm going to call it. I'm not going to do the examples for all the fractions for eighths, but 2 more. So if I wanted to make a fraction model to represent 4/8, I have to shade 4 out of the 8 parts in. So we still have 8 total parts, and we now have 4 of those 8 total parts shaded. And as you can see, 4/8 would also be equivalent to 1/2. About half of the shape here is shaded in, 4 out of the 8 parts. So for 5/8, I would simply shade in 1 additional square. So now we have 8 total parts, and 5 of those 8 parts are shaded. You know, I said I wasn't going to do all the examples for eighths. I changed my mind. I'll keep going. I'll finish it. So if I wanted 6/8, I shaded another square. We now have 8 total parts, and 6 of those 8 parts are shaded in. And yes, 6/8 is equivalent to 3/4. For 7/8, shade in another part. I still have 8 total parts, and 7 of those 8 parts are shaded, so this is the fraction model that represents 7/8. If I wanted to make 8/8, I would shade in the final part. 8 total parts, 8 parts are filled in, and this represents 8/8, which is also equal to 1 whole. Now there's so many other fractions I could do. I could do fifths, I could do sixths, I could do tenths, but I think you get the idea. New concept before I completely call it a video. I'm going to show you how to make some fraction models that represent mixed numbers. So what if we have a mixed number? What if we have 1 and 1/2? Well, I'll show you what a fraction model will represent that. So a halves means there's 2 total parts, right? And one of those 2 parts is shaded. Now 1 whole would be equal to 2 out of 2, right? So 1 whole would equal 2 total parts, 2 parts shaded. So this would equal 1 whole. Now 1/2, if we were to write that as an improper fraction, that would equal 3/2. So that means that we would need to make another square. All right, keep listening. I'm gonna get you unconfused. So we make another square with 2 equal parts, and we have to shade in one of those parts. So this is the fraction model that represents 1/2. So 3/2 and 1/2 are equal, like they're the same thing. 3/2 would be an improper fraction and 1/2 would be a mixed number, but they mean the same thing. It's basically just different ways of writing it. But you know what? I'm going to show you a few more things. I think you'll forget about the improper fraction. Forget I drew an improper fraction. I'm going to show you this to you in a different way. All right. So what if I were to do 2 wholes? Remember, 2/2 would be equal to 1 whole. 2 parts filled, 2 parts total, 2 parts filled. So if I were to make 2, I would shade in this other part. This is a fraction model that represents 2 wholes. Now, if I wanted to make 2.5, I would have to make another shape, and I would have to shade, that's 2 parts, and I would need to shade one of those 2 parts in. So this is the fraction model that represents 2.5. Now let's say I wanted to go to 3 wholes. And since we are dealing with shapes that are cut in half here, I'd have to shade the other part in. That's a fraction model that represents 3 wholes. If I wanted to go with 3 1/2, I have to make another shape, with 2 equal parts. And then I need to shade in one of those 2 parts. And now I have a fraction model that represents 3 1/2. So as you can see, we have 3 holes, we have 3 squares with 2 total parts, and both of the parts are shaded in 3 of our squares. Then we have a 4th square where one of the 2 parts is shaded. So we now have our visual fraction model for 3 1/2. All right, in the chat, the person that was confused before, put a 1 in the chat if you understand, put a 2 in the chat if you do not. Does it make sense? All right, put a 3 in the chat if you do not understand. If I don't see a 3 in the chat, I'm moving on. I'm going to assume everybody watching gets it. 3 in the chat if you don't understand. I'm going to give you all 10 seconds. 5, 4, 3, 2, 1. All right, I'm assuming everybody gets it. No 3s in the chat. Again, anybody who doesn't get it, put a 3 in the chat. All right, one more example of a mixed number. So let's say I have 2 1/4. So what I would need to do again, fourths would be a shape with 4 equal parts. Four equal parts. Now if I have 2 holes, I'm going to have 2 shapes where I'm going to have 2 squares where 4 out of the 4 parts are shaded. That represents my 2 holes. Since we have a mixed number 2 1/4, I would have to make a 3rd shape with 4 equal parts. And I would need to shade in one of those 4 parts. And that is our fraction model that represents 2 1/4. So we have 2 squares where 4 of the 4 parts are shaded, and then we have 1 square where 1 out of the 4 parts is shaded. And that is our model representing 2 1/4. All right, that is my live stream for today. Thank you so much for tuning in. Leave a comment. Let me know what you thought of the video, and if there is an area of math or reading that you're having difficulty with, put that in the comments, and I will do a future video on that skill. Until next time, this is Mr. Camilleri, signing off. It's the Mr. Camilleri show. It's the Mr. C. It's the Mr. Camilleri show. Shout out to Mr. C. One last thing before I completely sign off, if you have not already, remember to hit this button right here on my channel. Hit that subscribe button. Only if you want to. Alright, that is my video. See you all next time, I hope.